Ladies and gentlemen, here is your digital lesson. 5 Sum and Product of Roots. Now, that's the title of it, but it's not kind of really get out that way. But let's talk a little bit of nonsense for a second. Let's assume, now roots, another name for roots is solutions. And we've been doing different methods to find solutions to equations, right? We did quadratic formula. We did the completing the square. We did factoring. We found solutions. Well, let's assume for a second, solutions and roots is two different words that mean the same thing. Let's assume that R1 and R2 are the two solutions that we got from a quadratic equation, and we used factoring or whatever, and we got R1 and R2. Well, if you took the two answers and added them together, you should always get the negative b over a. And we're talking about a, b, c here. And if you take the two answers and multiply them together, you should always get, and there should be a little line here, c over a. And so from these two answers we get, and I'm going to blow this up even more, okay, so we're talking here, from these two answers we can learn kind of the coefficients of A, B, and C. Sometimes it gets a little tricky and we have to use a little bit of thought to get them, but we can certainly learn them. So this is adding and this is multiplying, so sum is adding, product is multiplying. Now, I put this way off to the side because that's where it comes from, but we're not going to necessarily do that. Okay, when given roots or zeros or solutions, okay, so now I just gave you three different words that all mean the same thing. When given those, look at example 1a, 2 and negative 5. Can we find the original equation? Well, yes. And we could do it through this sum and products bit. That's kind of cool and interesting and makes math kind of really, interesting, really. Interesting is the great word, excited, whatever. But basically what we're going to do to create any equation, we have to choose a variable. I like x. If you choose something else, that's fine. Just know that you're wrong. I like x, and so you will choose x because I like x. Okay, I'm going to just put my foot down right here, and you're not going to choose any other letter but x. But you can choose whatever you want. Just know that I like x. All you have to do is always, always, always go x minus whatever the root is. And so I'm going to go ahead and use that R1, R2. I hate writing R's, but I'm going to go ahead. So there's your first solution you got, and there's your second solution, and then all we have to do is multiply that out, and that will be our equation. So let me go backwards a bit and go here. See, I got 9 and negative 3 as a solution to this. If I were to go x minus 9 and x minus negative 3, minus negative, and multiply it out, I should go back to there. So that's what we're saying. If we get solutions, we can go backwards. So let me show you. It's not terrible. We always go x minus, and we're going to get double negatives at times. So if you're sharp and ahead of the game, you recognize, oh, it's minus, so it's going to turn into a plus. But otherwise, write them both and get that. Now we multiply, and you can use a box or distribute. I'm going to distribute x times x and x times 5. So x times x is x squared. X times 5 is 5x. And then we go negative 2 times x and negative 2 times 5. And so we get a negative 2x and a negative 10. And then we put these two together, and we get plus 3x minus 10, and wabang! Got it. So all you have to do ever, if these are the solutions or roots or it's all the same thing. You always go minus. If it's a negative, it's going to turn into a plus, but you always go minus, and then you multiply them out. So x squared minus 3x, and then we do the other ones. I used to do this in my head here. Minus 7x plus 21. Add those together, x squared minus 10x plus 21. This right here will give me, if I put equals on it, okay, I should pause it right here. It says find the original equation. To have an equation, you have to have an equal sign. So these technically should say equals 0. It's a minor detail, but it is a detail. We will put it in. Done. What about this one? Well, again, I talked to you about double negative. So x minus negative 4 is going to be plus, and x minus negative 9 is going to be plus. Okay, remember, it's minus a negative, so a double negative becomes plus. And it's supposed to equal 0. We'll put it up there. Put it on all of them. Okay, so now multiply it out, x times x and x times 9. So x squared plus 9x, and then 4 times x and 4 times 9, so 4x and 36. Add those together, x squared plus 13x plus 36. Boom, equals 0. Look, I got an equal 0 there. How about that, Jacob? Now, going to the next ones, the harder ones. The more difficult ones. Here we go. We got some imaginaries, and they're binomial imaginaries, and then we got some radicals. Now, these are going to start to play out with this idea of difference of squares. When we have 1 plus and 1 minus, it will be the first one squared minus the second one squared. We're going to remember that. So 2 roots, 2 plus 3i, 2 minus 3i. This is going to pay attention now. Okay, wake up, Jules. Minus, now technically, since it's a binomial, it should have parentheses, and then we're going to have parentheses around it. And then go like this, and we're going to 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 go like this. But I'm going to show you why these inside parentheses aren't going to make a big deal. You can kind of leave them off. Technically, you're supposed to distribute the minus sign on these things. And so what would it be? It will be x negative times 2 is negative 2. Negative times positive 3 is negative 3. Oh my gosh, this looks just like that. And then negative times 2 is negative 2, and negative times minus 3 is positive 3. Oh my gosh, this looks just like that. So technically this right here is kind of a frustration because we don't really need to put those extra parentheses, but technically that's what's going on. So cover it up, x minus 2 plus 3, and x minus 2 minus 3. Now, deep breath. Take a deep breath. All right. This is what we're going to do. We're going to clump these up. We're going to clump the x minus 2 together. Make that its own thing. Okay? So it now looks like this. Watch this. Now I'm going to change this bracket into square brackets because it will look better. This and this into square brackets. Okay, so all I did was make this parenthesis a square bracket because I'm going to take x minus 2 and put it in parentheses minus 3i. Then I'm going to take this x minus 2 and put it in parentheses plus 3i. Okay, so these square brackets, these parentheses and these square brackets, same thing, just different shape. Don't let that bug you. But if you look at this, okay, I have x minus 2 minus 3i, x minus 2 plus 3i. This is a minus b times a plus b, which I showed you earlier, a squared minus b squared. So this becomes, so exciting, a squared minus b squared. So x minus 2 squared minus, how do you take 3i? That's 9i squared. All of this right here, all of this right here, this whole beeswax becomes that. We're going to do 2 more, so don't worry. Now, we got to work here. This is going to be okay. We'll come back to here. We got to work this. This is x minus 2 times itself. Times itself. Now, there is a great pattern to this that I memorized, but they don't teach anymore. But and I'll show you if you ever ask. X times x, x times 2. X squared minus 2x. Negative 2 times x, negative 2 times negative 2. So negative 2x plus 4. Don't forget we have minus 9i squared. We'll take care of the I squared in a second, but let's take care. Negative 2, that's x squared minus 4x plus 4. Now, we're going to, I squared is negative 1, so we cross it out and change the sign here to a plus, and we get plus 9. Now, these two are like terms. We get x squared minus 4x plus 13 equals 0 because it is an equation, so we will put equals 0. Woo! Look at that. Crazy. That's crazy. I just heard Joey say that's crazy. Okay. Oh, you too, Noah. Okay. So, I'm going to put a blank. Okay. Here we go. Here we go. We go x minus x minus. Now, we do not, I'm going to put a red, orange little thing. We do not have to put these extra parentheses. Okay. That's technically what is happening, but we can get away with it because it just switches right there. So this is what we're going to do. This is what we're going to do. This is what we're going to do. We're going to start off with this here with the square bracket. We're going to go square bracket. X minus 5 plus 4i square bracket. Square bracket. Better use them. X minus 5 minus 4i. Always minus, no pluses. No pluses. It's always x minus, x minus, x minus, x minus on both of them. Let's zoom back in. We went x minus this here, x minus that there. Boom. Now, we are going to bunch together and save a little space at the same time. X minus 5, x minus 5. We're going to bunch that together, and this is x minus 5 is my A, 4i is my B, and so this is A, x minus 5, plus B, and then my A, x minus 5, minus B, which is A squared minus B squared. So now this is merely x minus 5 squared minus 4i squared, which I really I could have done that in my head, 16i squared. Now, I don't care when you deal with the I squared. I waited for a long time to deal with it because I wanted to focus on the squared here. But if you want to cross it out and put a plus, go right ahead. We'll just go, boom, that's boom, boom, ba. Okay. Don't laugh at me. So x minus 5 squared, again, squared means times itself. And so we have to go x times that, negative 5 times that, negative 5 times that. X times x is x squared, x times negative 5x, negative 5 times x, negative 5x, and negative 5 times negative 5 positive 25 plus 16. These two go together, these two go together. We get x squared minus 10x, 25 to the 30, 41. Equals 0 because it's an equation. Box it up for Christmas. And that. See, it's work, but it's okay. It's okay to work. It's okay to work hard. How are we going to do this with the radical? Radical works the same way. We are going to start off with square bracket x minus 8 plus square root 7 square bracket. Then we'll do another square bracket x minus 8 minus square root 7 square bracket. Now I'm using the square brackets because it creates a nice visual to everything. It's not necessary, like the very first problem I did. Okay, I put parentheses, but then when you get too many parentheses, it throws things off. And so by the time I got here, it's like, look, I don't want to see these parentheses with more parentheses. It's just lots of parentheses, and parentheses is hard to say too many times. So I'm going to do a square bracket instead of a parenthesis. It's exactly the same meaning, just a different shape. So technically over here, we could have done these in square brackets, and it's still the same shape. So now we are going to bunch it together. What is the same? The x minus 8. This is the key with all these problems. You always get an x minus something that is identical. Maybe it's x plus, but I think it's going to be minus. And so you can go x minus 8 and square root 7, and then this will be squared, and this will be squared, and minus. It is a squared minus b squared. You should see that pattern every single time. Sorry. Okay, so what is this? X squared minus, I was going to do it in my head for you. It's x minus 8 times x minus 8. And this is just square and square root cancel. This is just minus 7. The square and square roots are opposite cancels. Bingo. Okay, so now distribute. Now, when you do this, here's the pattern. I'm going to just teach it to you right now, okay, for all you smart people, Olivia. Okay, x times x times negative 8, negative 8 times x, negative 8 times negative 8. The way this works, you always get x times x squared. Negative 8 times x, or x times negative 8 is negative 8x. Negative 8 times that, negative 8x. You always get 2 of negative 8 times x. And then you get negative 8 squared, which is negative 8 times negative 8, positive 64. Okay, and I'll write the pattern down at the bottom for those of you who want it. For those of you who are like, are you kidding me? Don't even pay attention to it. Just do what I tell you here. Negative 8 is made out of negative 16. And then 64 minus 7 is 57. And it equals 0 because it's an equation. Bingo. So here it is. For those of you who are brainiacs, if you have a plus or minus b quantity squared, meaning a plus b times a plus b, or a minus b times a minus b, then the pattern is a squared plus or maybe minus, depending, 2a times b plus b squared. This is what it always, and if you look at all of my answers here, x minus 8 squared, I got x squared, that's a. I got b 8 squared, that's b squared. And then when I multiply them both together and multiply times 2, okay, same thing here. X squared, boom, 5 squared, 25. And then 5 times x times 2. So this is if you want it. This is if you want it. If you want to memorize that a plus b or a minus b squared is this pattern, you're welcome to memorize that. It's kind of cool, but I would only recognize that for those who are like, hey, I'm really good at math. Otherwise, just do what I say. Now, some of this got to be really confusing to some people. Will you please work together and help each other out? Okay? Please. Love you guys. Take care.